Guys, today we're going to talk about relations and functions. A relation is just a set of inputs and outputs. So far in your mathematical career, your inputs have been known as your x values, and your outputs are your y values. These guys, of course, have other names. Two very popular ones. We have domain and range. We also have dependent. Oh, that one's not the dependent one. Dependent and independent. So you might see some of these words pop up ever so often. They all just mean your x and y value. A function is a relation with one output for every input. So each x value has exactly one y value. Below I found this little picture online. You can probably easily find it too. You see here, if we have these x values and these y values, each x value just directly shows one y value. Y values can have more than one x values, but each x value needs one y. So if you look over on this side, this 9 is going to both 3 and negative 3. So it is not a function because of that. And the same thing for this guy. Whoa. This 3 has 5 and 6. It is not a function because the x values need exactly one y. On a graph, a relation is a function if and only if no vertical line passes through two or more points on a graph. We call this the vertical line test. So if I'm just drawing a, well, that's not a good line. If I'm just drawing a quick graph here, and I had a graph that looked like something like this, I can go through here and draw a vertical line anywhere I wanted in here, and these lines will only cross through one time. Now let's say I had a graph that looked like this dude. If I cross a vertical line here, you see that it crosses two times, so this is not a function. And it only needs to pass through one time. So let's say we had a function, oh, where am I going to squeeze this? Right here. Let's say we had a function that looked like this dude. It was like that, and then it was like that. Because when I draw a vertical line right here, it crosses here and here, it is not a function. Vertical line test. It's pretty cool. Function notation. This is what I'm super excited for because I hate using y so much. Mathematicians, again, we want to name things different things. We can't just keep using y sub 1, y sub 2, all that nonsense. So we have this new kind of thing. It's called function notation. For the most part, you will see f of x. That means the function of x and the input. Oh my goodness. Let's rewind. The function of f with the input x. So my output value is f of x. My input is x. You can switch out your function name. So you'll see popular ones are like g of x, h of x, any letter of the alphabet really. It's just to give, if we have more than one line on a graph, a new name. So I could have a graph. I could have. I could have a graph. I could have this line right here, and then this line right here. I can name this one g of x, and this one f of x. So then when I talk about the lines individually, nobody gets confused. So we're going to go ahead and use this. Starting off simply, just evaluating. So I have f of x is equal to 2x minus 3. We need to find out what that function is equal to when x is equal to negative 2. So just like in any other, you will substitute negative 2 in for your x. Whoop. But then our function will look like f of negative 2. So this says in my function, when x is equal to negative 2, my function, my output value is equal to negative 7. So really this is telling me my coordinate point, negative 2, comma, negative 7. Try this one out real quick. Pause the video, please. Did you pause it? I know you guys didn't pause it. That's so rude. That's so rude. All right, so we want to find out when x is equal to 0 in my function g of x. So I'm going to substitute 0 in. Negative 5 times 0. So g of 0 is equal to, equal to 0. So when x is equal to 0, my function is equal to 0 as well. We can do a bit more with these. So given this information below, we want to find the slope. I know that f of negative 4 is equal to 5, and f of 3 is equal to negative 2. Now again, usually we see f of x, so I know that the numbers inside the parentheses there, those are my x values. So this one would be negative 4, this one it would be 3. And then what the function is equal to is really just my y value. So for this first one, 5, second one, negative 2. Close parenthesis. So really this stuff here, because all the letters, it looks a little confusing, but it's really just 2 coordinate points they're giving you. Then we can go ahead and find the slope. 5 minus negative 2 over negative 4 minus 3. Boom, boom, bam, boom, boom, bop, 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 bop. My slope is equal to negative 1. Just to go over it again, I have h of 3 is equal to 4, and h of 5 is equal to 7. Again, these guys are just giving you coordinate points. So we want to find the slope. We can use our slope formula again. 7 minus 4 over 5 minus 3. I get 3 over 2. What a beautiful slope. Yeah, that's it. If you have any questions, please let me know. Okay, bye.